HC over lambda gives us what?
Energy.
Energy. Cool. And this equation is combining two different ones. Because, what is it? Because it's usually
H times V.
H times V, you said?
Well, no, that one's right.
Oh, right, yeah.
But there's also H times V will also give you
Equals
energy.
HV, perfect, yeah. And so we basically just solve for frequency with the other, because C is equal to lambda times frequency, right?
Yeah.
And so he just basically added these two equations together to give you this one. So that's helpful. And we just have to remember that C over lambda is equal to the frequency. So, cool. So using this equation, we just need to use our calculator. We can solve for the energy. And C and H are constants, right?
Right.
C is the speed of light, which is 3.0 times 10 to the 8th, right? H is Planck's constant, which is like 1.6, is that right? I'm trying to remember.
6.626.
6.626 times 10 to the
Negative 34.
negative 34. Cool. So those are all the constants that you need to remember for this.
So wavelength in meters, and this is in nanometers.
Perfect. Way to catch that.
It's 512 nanometers.
So this gives us, if we just solved for this wavelength, what do we get?
Are you using nanometers?
We can use meters and then convert, or we can convert from the beginning. Which way did you do?
I did it just the regular way, without converting.
Okay, so you solved for wavelength right here.
Yep.
And then what was this answer?
Well, I actually used just the HC divided by wavelength, which was...
Oh, we're solving for energy. That's right, I thought we were solving for wavelength, sorry. Okay, yeah, you're right. So we're solving for energy. So for this wavelength, they give us what value? It's like 500 and...
512 nanometers.
Okay, so what did you do to convert this to meters?
512 times 9. Times 10 to the 9.
It would be to the -9, right?
-9.
Because meters are bigger than nanometers. And so if we have the small unit and we're going to the bigger one, the number is just going to get smaller.
Okay.
And so you're right, though, we would use 9 because the nano for 9. And so we would just take the decimal place that's right here, and we can just move it over 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should end up being like 5.12 times 10 to the -9th, or 7th, sorry, meters.
show up.
Oh, really? Okay, let's go through it. So we've got, what answer did we get?
I got 1.885.
Times 10 to the negative ninth.
That was part of the other answer.
Oh, okay.
So all I took was Planck's constant times speed of light. So then I divided it by
that calculator, if you don't put things in parentheses, it will mess you up. I don't know why the calculator doesn't follow the rules, but yeah, I have that same calculator that you do, and I put every single thing in parentheses just because it's messed me up before. And so we knew that this was going to be like 5.12 times 10 to the negative 7. So our exponent should be, we should get something times 10 to the negative 19th. Put this in parentheses as well.
So how you know it goes to the negative 19th?
Just the way that the exponents will add up. So if you're multiplying and dividing, then you can add or subtract. And so if you're multiplying, you'll add these two exponents together. And then if you're dividing, you'll subtract. But because this is a negative exponent, we add it. And so it's going to be ending up to be negative 34 plus 15. And so we just add those together, and that gives us negative 19. But then we have a 6 times 3, so we can just, if we just do rounding, just to make it easy, 6 times 3 will be 18 divided by 5. So our answer is going to be around 3 something times 10 to the negative 19th. Is that one of the answers?
Yeah, it's a process of elimination without even doing the math.
Yeah. So that's just a really quick way of doing it without getting an exact answer. But let's try and put it in your calculator again, because you're going to want to know how to do that.
So 6.626, and then you do that, right?
I just do, because if you just do this,
Yeah.
then it's raising it to that power. So you could do it that way. Or if you do second log, it does the 10 times to 10 to the automatically.
Sure.
And then the parentheses, and then I click equal. And so then it has that value, and then you can click say times, and then put parentheses around this next answer. And then we do 3 times 10 to the 8th.
And then we'll do that again.
Yep, and then click equals, and then divide, and then parentheses. 5.12 times 10 to the negative 7th. And then it gave us 3.8. Yeah, it's that calculator, unless you, for some reason it'll carry the 10 times whatever to the next thing or whatever else. Yeah, and so I just always put everything in parentheses. So, cool. But yeah, so if you're ever stuck and you, for some reason, can't get the right answer on the calculator, then just remembering how the exponents add up, and then you can just make these into easier numbers to use and come up with something like that.